Alright, today we're showing that a quadrilateral is a parallelogram. Alright, we're trying to prove we have a parallelogram. So when can we do that? Alright, if both pairs of opposite sides, segment BC congruent segment AD and segment AB congruent segment CD, if both pairs of opposite sides are congruent, then we have a parallelogram. Alright? Same thing if in a figure, if both pairs of opposite angles, angle B and angle D, and angle A and angle C, if both pairs of opposite angles are congruent, then you have a parallelogram. Alright, so we're proving we have a parallelogram. So we don't know we have two pairs of opposite sides that are parallel. Alright, we have a figure, four-sided figure, a quadrilateral. We know, the only thing we know is that both pairs of opposite sides are congruent. Great, we know we have a parallelogram. Or we know both pairs of opposite angles are congruent. We now know we have a parallelogram. Alright, here, those adjustable hoop basketball hoops, alright, what makes this backboard always stay parallel to the pole that's in the ground? You know, when you raise and lower this backboard, what makes that the backboard parallel to the pole? Okay, and if we look at the supports here, segment CD is 36 inches, segment AB is 36 inches, the support on the backboard, A to D, is 18 inches, and the support on the hoop is BC is 18 inches. Alright, so in the diagram to the right, segment AB and segment DC represent adjustable supports of a basketball hoop. Explain why segment AD is always parallel to BC. Why is the hoop, the backboard, always parallel to the pole? And it goes back to this definition. If both pairs of opposite sides are congruent, then it's a parallelogram. Okay? Both pairs of opposite sides are congruent, we then have a parallelogram. Alright, another theorem, alright? If you have one pair of sides, so one pair of opposite sides, excuse me, segment BC and segment AD, they're congruent and they are parallel. Alright, so if one pair of opposite sides are parallel and congruent, then you have a parallelogram. Alright, it has to be the same pair of sides. They're parallel and they are congruent. Another theorem of quadrilaterals, okay, if the diagonals bisect each other. If the diagonals of a quadrilateral bisect each other, then that quadrilateral is a parallelogram. Alright, so for what value of x is this quadrilateral PQRS a parallelogram? So what will make this a parallelogram? What has to be true? Well, we're looking at the diagonals here, so what has to be true about the diagonals? They have to, segment QS, which is the one diagonal, and segment PR, they have to bisect each other. Well, right now we already know that segment QT, and it is a cutie, alright, segment QT is congruent segment ST by the markings here. So, what has to be true about segment PT and segment RT? They have to be congruent, right? The segments have to be congruent. Well, if the segments have to be congruent, that means the lengths of them have to be equal. And the length of PT is 5x, and the length of RT is 2x plus 9. Alright? So we've taken a geometric concept to set up an algebraic equation yet again. So we subtract 2x from both sides. We get 3x equals 9. Divide by 3. X equals 3. Okay, so for what value of x is this quadrilateral PQRS a parallelogram? When x equals 3. And if we check, 5 times 3 is 15. 2 times 3 is 6. Plus 9 is 15. Yep, they're congruent. Alright, here are just the 5 things about a parallelogram now. Alright? What makes a parallelogram? These are the 5 things we've talked about. Alright? Obviously, if you show both pairs of opposite sides are parallel, you're going to have a parallelogram. If both pairs of opposite sides are congruent, it's a parallelogram. If both pairs of opposite angles are congruent, it's a parallelogram. If one pair of opposite sides are parallel and congruent, it's a parallelogram. And lastly, if the diagonals bisect each other, it's a parallelogram. Alright, show that quadrilateral KLMN is a parallelogram. So we have the figure in the coordinate plane here. How can we prove or show that this is a parallelogram? Well, we would want to show one of these 5 ways here. Okay, if we're going to use this first one to show that this figure is a parallelogram, how do you show both sides are parallel? What are we looking at there? We're looking at their slopes, so we'd use the slope formula. Okay, and obviously those slopes would have to be equal. If we're going to show both pairs of opposite sides are congruent in this figure, how are we going to do that? How are we going to show that segment KN is congruent to segment LM? How segment MN is congruent to segment LK? Alright, we have segments in the coordinate plane. We're going to have to use the distance formula. And obviously the opposite sides would have to be congruent, both pairs. Angles, we can't do anything with angles, right? We don't have any tools where we can find out what that exact angle measure is. The only time we could is if all the angles were right angles, because we can show lines are perpendicular, but other than that we can't show this one. We can't prove this one. Okay? The fourth one here, alright, showing one pair of opposite sides are parallel and congruent. Well, parallel, congruent, alright? So you'd have to use slope formula. And you'd have to use the distance formula. Okay? And now the last one here, show the diagonals bisect each other. Alright, if we're looking at this figure here, diagonal LN and diagonal MK, alright, how are we going to show if those diagonals bisect each other? Well, that point where they intersect. I want to look more closely at that point that they intersect at. Right, this point here. What do we know about that point? Okay, and I don't care, we can call it P. What do we know about point P? Do we know anything? If the diagonals are going to bisect each other, point P has to be the midpoint. So we'd be using the midpoint formula. Alright, and all these tools that we'd use, we have used before. Okay, and there's nothing new here. Alright, so proving you have a parallelogram here, and I'm going to use the midpoint formula since I have the diagonals drawn on here quick. Alright, and you should be able to prove this multiple ways. You will be asked at some point to prove this, not necessarily just this figure. You know, a figure in the coordinate plane, you're going to be asked to prove that it is a parallelogram, and you're going to need to do it 2 different ways. Alright, so make sure you know 2 different ways here. I don't care what 2, but make sure you know 2 ways. Alright, I'm going to do the midpoint formula here. So if I find the midpoint, or point P, okay, of segment MK, alright, the midpoint formula is 6 plus 2 divided by 2. 0 plus 2 divided by 2. So point P is 6 plus 2 is 8 divided by 2. 0 plus 2 is 2 divided by 2. So that point P for segment, this here I'm doing for segment MK. Alright, 8 divided by 2 is 4. 2 divided by 2 is 1. Okay? Do the same thing for segment LN. Alright, point P. Is it the same? Alright? Well, I got 4 plus 4 divided by 2. 4 plus negative 2 divided by 2. So point P is 4 plus 4 is 8 divided by 2. 4 plus negative 2, that's 2 divided by 2. So point P is at 4, 1. They're the same for both segments. What does that tell us? That tells us that the diagonals bisect each other. So yes, it is a parallelogram. Alright? knowing the midpoint is the same for both of those diagonals, okay, therefore, 3 dots means therefore, the diagonals bisect each other alright, and then because of that, okay, if the diagonals bisect each other, then it's a parallelogram. Okay? So, please come to class proving that is a parallelogram one other way. Alright? Please come to class having proved that is a parallelogram in another manner. And like I said, you have 4 different ways to do that. Alright? Well, I use this one. So you have 3 other choices to choose from to prove you have a parallelogram. Okay? Thanks a lot.